ReLU stands for Rectified Linear Unit. It is the most popular activation function in modern deep learning. It simply outputs the input if positive, otherwise 0. The formula is extremely simple. ReLU x max 0x. If the input is greater than 0, it returns the input. Otherwise, it returns 0. ReLU creates a graph that looks like a hockey stick. It's linear for positive values and flat 0 for negative values. Very simple and efficient. However, ReLU has a drawback. Neurons can die. If they always output 0, they stop learning. This is called the dying ReLU problem. To fix dying ReLU, variants were created: Leaky ReLU, parametric ReLU, and ELU. They allow a small negative slope instead of strict 0. Unlike sigmoid and tanh, ReLU doesn't suffer from vanishing gradients in positive region and trains much faster, which is why it dominates hidden layers today. Big advantages: sparse activation, faster convergence, biologically plausible, and avoids saturation unlike sigmoid and tanh.
ReLU is computationally very cheap, has no upper limit, helps solve vanishing gradient problem, and enables faster training in deep networks.
Use ReLU in most hidden layers of deep neural networks. It's the default choice in CNNs and transformers. For output layers, use sigmoid or softmax.